Okay, today we're going over 8.4 properties of logarithms. So we're going to be looking at three different properties here. And the first one we have is the product property. So this is saying that if we have a log and we have the same base b and we're multiplying m times n, then that is equivalent to adding your logs. So when you have a product here, you're going to add your logs. And you can remember that because we know that when we use exponents, for example, if I have x to the fifth times x cubed, here we're multiplying and we have the same base and we have exponents. So what we do here is we do the same thing that we would for logs. We add the exponents. So this is only when you have the same base. You would add the exponents, which would be the same as adding the logs here. This works for both exponents and logarithms because they are inverses of each other, so they share the same properties. Okay, the next property is the quotient property, and that is if we're dividing m divided by n, then we would subtract the logs. For example, if I was going to take the same kind of thing here of x to the fifth divided by x cubed here. Here I have the same base and I'm dividing them, and now we all know that we would subtract the exponents. So we have x to the 5 minus 3 is x squared. So I'm subtracting my exponents here, and that would be the same for the logs. You subtract the logs. That is by the quotient property, and it would be the same with the exponents and logs. The next property is your power property, and that's when we take this, whatever the power is, and you're going to bring it in front. So whatever the power is, we bring it in front, and it'll be x times log base b of m. That's by the power property. So here are our three properties, and we're going to have to go both ways. So this is a single log, and to expand it, I'd write it as log base b of m plus log base b of n, and I would have to go the other way as well. So if it's written like this, and I need to write it as a single log, I know that when I'm adding my logs, I have to multiply m and n. Same thing here, if I'm subtracting my logs, I have to divide m over n. And same thing with this one, if there's a number in front, then that would be the exponent for m. So you'd put it as the power. Okay, so let's just go over a couple of things here. We will first look at writing the logarithmic expression as a single log, so only one log. So we first make sure that we have the same thing written as the base. So here we have the same base written in. The base is a 3, and then we know we're subtracting the logs. So when we subtract the logs, we'll keep that base 3 and we divide these numbers, 20 over 4. So that will give us log base 3 of 5, and that's written as a single log. Alright, this one here, we'll first take this 3 and bring it to the power, the exponent. So we'll have log base 2 of x cubed plus log base 2 of y. And now that they have the same base and we're adding the logs, that means I'm going to multiply and have log base 2 of x cubed times y. That is writing it as a single log. Moving on for expanding each log. So here we're dividing them, so we'll subtract the logs, log base 5 of x minus log base 5 of y. This one here, we need to make sure that we know that if it says, for example, y equals log of x, then we know that since there's no base written in, that's the same as writing log base 10 of x, and we should have seen this in the 8.3 video, that this is called a common log. So common logs have a base of 10, and you can actually evaluate these on your calculators. We'll learn that later on as well. So here we do have a common log. You don't have to write the base 10 in though, because it's just known that it is a base of 10. It's kind of like if I wrote an x, that is just known that that's x to the first power. Okay, so moving on here, I have log base 10, but I'm not going to write the base in because it's a common log. Log of 3, I'm going to add them because when we multiply these, I add the logs. Log of r to the 4th, and then I'm going to bring this 4 in front by using the power property. I get log of 3 plus 4 log of r. Do one more of these here. So this 2, since this whole thing is in parentheses, everything is squared, so I can put a 2 and then write all of this in parentheses of log of y. Since I'm dividing these, I'll subtract the logs, log of 3, and then closing my parentheses, because this shows that the 2 is the exponent for y and for 3. Alright, if we move on here, we can see that this is 7 times 2x minus 3 squared. So since it's times, we'll use the product property here, and we'll get log base 3 of 7 plus log base 3 of 2x minus 3 squared, and then I'll bring this 2 in front by the power property. I get log base 3 of 7 plus 2 log base 3 of 2x minus 3. And that's simplified. That's expanding the log. Alright, if we look here, we have a radical, and we don't have any radical properties. So if we just remember a couple things here, for example, if I say what is going to be the 4th root of x cubed. So we need to remember that I can use power over root to change this radical form to exponent form. So here I'll have a base of x, my power is a 3, and my root is a 4. So this is the same as x to the 3/4. And we want to change it to exponent form because we have a power property. We don't have a radical property. So if we have the square root of x, we know that if there's no power written in, it's a 1. And if there's no root written in, it's a 2, square root. So this will be the same as x to the 1/2 power. So if we rewrite this one here, this is log of 2x over y all to the 1/2 power, because our power is a 1 and our root is a 2, and it's all underneath the radical. So now we can bring this half to the front, and we'll have to put it in parentheses because everything is to the 1/2 power. So I'll have a half log of 2x. I'm dividing here, so minus log of y. And then I have to break this up a little bit more, expand this even more, of log of 2. Since we have 2 times x, we will use our product property and add the log, so plus log of x minus log of y. Okay, one more here. If we have a square root, we can try and simplify it first. So I'll have log of 2. We know that the square root of 4 is a 2. The square root of r, we can't simplify that, so we'll just write the square root of r. And the square root of s squared, the square root and squared will cancel, or again, you can use power over root as 2 over 2 is a 1, and that's s to the first, or just s. So if we continue here, we'll have log of 2 times 2 is a 4. R to the 1/2 is the same as r to the, the square root of r is the same as r to the 1/2. And that's because I used my power is a 1 and my root is a 2. So that's the same as r to the 1/2. So continuing here, I'll have log of 4 plus log of r to the 1/2. And then minus, because it's dividing, minus log of s. And then we'll just have one more step to do, which is to bring the half in front. So I'll have log of 4 plus a half log r minus log s. All right, one more problem here to wrap it up. So just like when we had radicals, we changed it to have exponents. Now, if we're dividing by a number here, we know that we have a property if there's a number in front of the logs. So we're going to change it so that there's a number in front of the logs instead of dividing by a number here. So dividing by 4 is the same as multiplying by 1/4. So I'm going to write this as 1/4 log of z minus log of 3. And then this will be minus 5/2 log of x. So this 1/4 is going to be an exponent for z and for the 3. And the 5/2 will be an exponent for your x. So I have log of z to the 1/4 minus log of 3 to the 1/4 minus log of x to the 5/2. And then we can write that as using our quotient property. Log of z to the 1/4. Since this says minus, I'm going to put this 3 to the 1/4 in the denominator. And again, we have a minus, which means I'm going to put this x to the 5/2 in the denominator as well. You can also see that if I took this negative and I put that in the exponent, we know that then what would happen here is this would be a plus log x to the negative 5/2. And if we have a negative exponent, we know to bring that to the denominator. So that's another way to look at this as well. If you have a negative exponent, it goes into the denominator. And this is fine here. It doesn't say to write it in radical form, or it doesn't specify which form to write it in except to make it a single log. So that's good for this one. And that's all for today. Thanks for listening.